Okay, two variable inequalities. Notice here we have it with the y's already by itself. So we're going to treat this as a y equals mx plus b, where the y-intercept, the slope is 2 over 1, and the y-intercept is 3. So I can put a dot at 3, and I'm going to go up 2 over 1. Now notice this is a line with a bar underneath of it. So I can graph, that's my y-intercept. There's my line. We'll draw a line, and I'll make it a solid line. And then what I do is this. If I pretend I'm standing on this line, I'm looking at y. Are the y's smaller or larger? The y's are smaller, so I'm going to shade it down here. All right. Now I'm going to go to the second problem. Notice it's y in the form y equals mx plus b. So my slope here is a negative 1 over 1, and my y-intercept is at 1. So I'm going to go put a dot at the y-intercept at 1, and then I'm going to go down 1 over 1 to put the second dot like I did here. But this time, there's no bar underneath the line, so it's going to be a dotted line. And once again, just like before, pretend I'm standing on this red line. And am I looking for y values that are smaller or larger? Smaller. So that means my answer is in this area right here, below both of these lines. So is 0, 0 part of the solution? Well, let's put a dot. 0, 0 is in this area, so it is part of the solution. Negative 2, negative 1. If I put a dot, it's on this line here. Notice if it's on this line here, it is still part of the solution. So the answer is yes. But at 2, 7, my dot is up here, and notice it's on this line, but it's not in both the red and the blue, so therefore it is not part of the solution. Now, if I want to do it with the calculator, I would simply go up here to add graphs. I would make sure to hit the delete to go back to my relation function, and then I can choose the one of these that I want. In this case, it would be the option 1, and I would type the equation in, and then I would do it again to type in the second one, and it graphs them both for me. And as you can see right here, the dots, and you can see where they fall on these lines. This is a much neater dot because it was done with the calculator than my hand-drawn one.